Okay, I think we can start. So welcome everyone. Good afternoon. Thank you very much for joining this new session of the Urban Model Seminar. I'm Clementine and together with Ruta. Today we're very happy to see you again for this. I think it's the 8th session of the seminar where we discuss analytical urban models and their circulation. So some of you might be used to it now. Once a month, we receive an expert of urban studies and modeling to dissect one model with a general question in mind. This question is, in general, what are the unforeseen consequences of urban model simplifications on our understanding of cities? So we go through models' history, biography, circulation to understand how they've shaped our understanding of cities. Because urban models are simplifications of reality, simplifications that also translate modeling choices, implicit or explicit, and we try to analyze their consequences on how we view, how we represent, and how we can act afterwards on cities. So we try to trace the discrepancy between the model results and empirical analysis back to the model's core assumptions and design choices, in the aim of providing guidance on how to use classical urban models appropriately, avoiding misleading conclusions, and ultimately to create better models from those building blocks. So last month we had in this seminar, we received Itzhak Benenson and Aris Hatna to talk about the unforeseen consequences on shelling on the segregation modeling. The recording, if you're interested and if you've missed the session, is available on our YouTube channel, Urban Model Seminar. Today, I'm very happy and honored to receive Mike Batty to talk about Forrester and his Urban Dynamics model. So Mike, you didn't send us a biography, but it's quite easy to do your biography because you've got a Wikipedia page. So according to your Wikipedia page, you're a British urban planner and geographer, Bartlett Professor of Planning at University College London. And also from my own sources, you're the founder, former director and chairman of the Center of Advanced Spatial Analysis, CASA. And your work is focused on computer model and of city systems. So you've received loads of prizes that I might not cite all of them, but what I find really impressive is that not only you're recognized by very significant prizes, but also in a wide array of associations from regional science to complex systems to geography to planning. So that's probably all I will say because most of our audience probably know about you. But today you will present Forrester's Urban Dynamics model, its assumptions and its impact on shaping the imaginary of urban modeling and policy action. Hopefully you will reflect on the model's formalism of stocks and flows to discuss its controversial conception and reception in academic and policy communities, as well as its consequences on urban dynamics and policies. So the way it works is that I will hand over to you in a couple of seconds. You will have 40 to 50 minutes for the presentation, and then we'll take the questions at the end of the talk. At any moment during your talk, anyone can ask a question. Please use the chat for that. And Ruta will be moderating the chat. She can ask your question at the end if you prefer. You can also ask them yourself, just indicate it in the chat when you ask a question. So I think that's it for me. Thank you very much to the numerous people who joined today. And thank you most of all, Mike, for accepting to present on this topic.
Okay, thanks very much, Clementine. Let me share my screen. Okay. Let's have a look. Just put it into screen mode. Okay. Okay, well, as Clementine has said, I'm going to talk about Forrester's Urban Dynamics model. In fact, I'm really going to talk about the broader context of what Forrester was doing, because he was there right at the very beginning, really, of the urban modeling movement to some extent, not at the actual inception, really. The first urban models were built in the mid-1950s in Chicago, basically, but Forrester was very active during that period. So I'm going to say something about him, but let me tell you what I'm going to talk about in the next 45 minutes. it's all about what happened between about 1965 and 1972. So to some extent, this is really the history. And I'm going to really begin with talking a little bit about the genesis of urban models. This relates to a special issue of the Journal of the American Institute of Planners in 1965 called Urban Development Models, edited by Britton Harris, who was one of the kind of key pioneers really in that sense. And that really dated my baptism into this sort of particular movement. I was a student in 1965 of architecture and planning at Manchester, and we were introduced to this, and to some extent it really meshed, I think, with a lot of our thinking of those times. So I'll say a little bit about that, and then about dynamics and disaggregation. One of the kind of key features of the early urban modeling movement was that we really couldn't build temporally dynamic or disaggregated models. The data simply wasn't there. But the point I'm going to make several times is that these ideas about dynamics and disaggregation, which are very key to how we want to think about the world, they were very, very central to what we were thinking about. The fact that we couldn't do anything about them because the data wasn't there really was almost incidental. And of course, in 1969, a number of these models had been built by then, into this sort of activity came J. Forrester with his urban dynamics model, almost out of the blue to some extent. So I'll bring you up to date and talk a little bit about J. Forrester, basically, and then I'll tell you about how we met or didn't meet actually J. Forrester in America. I'm going to say something about America in 1970 because that's very important too, and then I'll talk about dynamics and urban models. It's a long, difficult quest, and Forrester was quite influential in many ways, not so much in building particular urban models, but actually influencing how we thought about them. And of course, his urban dynamics led to world dynamics, which was the modeling that was done for the world system in that sense, the Earth system in this particular context in terms of long-term resources. And that was what was called world dynamics, which followed his book Urban Dynamics about 2 or 3 years later in 1972. So I'm going to tell you really all about that. Okay, now the genesis of urban models. I mentioned the fact that in 1965, the Journal of the American Institute of Planners had this special issue on urban development models, and most of the models that had been built in the United States were contained in that particular special issue. And it really kind of was a revelation in many senses to us as students, in a way, that it always appeared that you could actually think about cities in systematic and scientific terms, but of course very few people had really done much about this in that sense. So the JAIP, the AIP journal special issue really kind of crystallized all of this. I was a student at the University of Manchester in architecture and planning, and two of our tutors there, George Chadwick and Brian McLaughlin, were also developing similar ideas, which led to their two respective books in 1969 and 1971. Brian McLaughlin's book, Urban and Regional Planning, a Systems Approach, basically, and then George Chadwick's book, 1971. So this was the ferment of ideas. I basically graduated in 1966, I think, and then actually spent 3 years doing research at Manchester in the department. I was the only PhD student. They'd never had PhD students before in that sense. And of course, that's where I learned how to program painfully in Atlas Autocode, basically, Algol, in some sense, on the for anti-Mark I Atlas machine, basically, in that sense. And my own research was really more in design methods, and it was almost an accident of fate that I got involved in urban models. And that was largely because as part of my graduate education, I basically took a course in matrix algebra in that sense. And somebody came to me with an input-output model and wanted to know how it worked, basically. So I could actually all understand that because I knew about the matrix algebra in that sense. And that pushed me very strongly into modeling in this particular context. So let me continue the story. Urban land use models or urban development models or land use transportation models. This is what we call them now, LUTI models, although effectively land use is sort of implicit in it in a sense. We're talking about activity allocation of employment and population by and large in these sorts of models. These were models that really were built from 1955 onwards. The Chicago Area Transportation Study was the first. Actually, that's not quite true. The Detroit Area Transportation Study was a couple of years before Chicago, but this led to this great wave of modeling, transport modeling initially, leading to then the extension into land use in that sense. And certainly by the mid-1960s, there were quite a lot of these models. The model that was built for Pittsburgh by Ira Lowry, which was part of this basically, was probably the quintessential variant in that sense. It was a static equilibrium model. It was built in this way largely because people could not look at the dynamics, although we wanted to look at dynamics in those days, and we wanted to also look at disaggregate populations and so on. The difficulty was essentially with the data. So Larry's model really pretty typical of the sort of tensions at that time. It was a static general equilibrium model, an instant metropolis, he called it in this particular context. And essentially it put together two basic ideas. One was the idea of the economic base theory, in a sense. Economic multipliers were used to actually scale activities up, and the activities themselves, population and employment of various sorts, were actually distributed using gravity models. I'll show you a picture of Larry's model in a moment. Now, one absolutely key issue in all of this, which I really want to emphasize, is that we didn't think that the best way of building models of cities was to treat the city in equilibrium in that sense. It was largely because we simply didn't have data at different points of time. This was the reason why the models were at one point in time. And secondly, disaggregated data was very problematic in this sense. And we'll see in a moment some of the examples. Larry's model was quite detailed in many senses, but once Larry produced his model in the early 1960s, there were versions of it which were actually dynamic. John Cressine, for example, built the TOMS model, which was time-orientated metropolitan model system, in that sense, again for Pittsburgh, using Larry's code in this sense. And so, in other words, there were dynamic variants of these models at the time, but they were painful. They were not dynamics in the sense that Forrester came onto the scene and talked about long-term dynamics. They were really short-term dynamics. It was a bit like applying the static spatial equilibrium at a cross-section in time in this way. Now, this was Larry's model, basically. So this is the sort of the benchmark, if you like, from the 1960s. There's his monograph, which you can get online, the RAND Corporation, Research and National Development, where he worked after Pittsburgh. And then you can see the picture of Pittsburgh itself and how he actually divided Pittsburgh into really grid squares to some extent, but he organized it so that these grid squares basically reflected to some extent administrative boundaries at a small scale. And you can see the model itself, the structure of the model, that's a more recent rendition. The structure of the model basically were, let me tell you how it works. You start with employment, and that generates trips. Use a gravity model to generate where people live. Where people live demands, they demand where they need to be serviced in some sense by employment, other employment, and we have this loop from employment to population and back again, which is the circularity in that sense. And we drive it basically by starting with a distribution of employment and population. And under certain variants, we're able to actually generate more employment using multiplier effects, essentially, if we start with basic employment. And the other version, of course, is that we iterate in this sense so that we get a balance between employment and population. And if you look at Larry's model of metropolis, then it is really all about that, basically, that it was a rather complete model in some senses compared with many of the other models which were developed at the time. Okay, and in fact, if you want to look at this, if you want to look at my early book in 1976, then this tells you a little bit about Larry's model in the first few chapters in that sense. Okay, so this is not really about Lowry's work, basically, although it's about the beginnings of urban modeling. It's really about J. Forrester. So let me tell you a bit about J. Forrester, very interesting person. He was an electrical engineer. He was born on a farm in Nebraska in 1918, but as is the way in America, you can't keep good people down, basically. He found his way very quickly to MIT. And at the end of the war, he was actually in the Lincoln labs, which were basically the electrical engineering labs, basically. And he led what was called the Whirlwind Computer Project. Now, 1918, he would be, at the end of the war, he'd be in his late 20s, I guess. In this particular context, so quite a young man in that sense, building the Whirlwind computer, which is the basis of the SAGE missile system. Again, to take you back to those years in the United States, then basically the Cold War was beginning, and in that sense, we were putting missile systems in place all the time. The Manhattan Project had led to the hydrogen bomb and things of that sort, basically. And all of this was tied up with what was going on at places like MIT and the University of Pennsylvania and so on, etc. J. Forrester basically was a computer engineer. He ran the project. He held many patents for computer hardware. This was after the war. The magnetic core in the early mainframe machines was held by him. And like Turing and von Neumann and various people at the time, he thought of the computer as a universal machine. It could play music, do graphics, and so on. But most of the time, of course, at this particular time, computers were actually doing scientific problems in this particular context. Here's a picture of the Whirlwind computer. Basically, that's what computers looked like, mainframes in those days. This is the late 1940s in a sense. And you can also see somebody looking at an oscilloscope, basically, in a sense. And of course, the key issue here is that the translation of computing from numbers to graphics was something that Forrester really pushed in a way. He was one of several people who pushed towards the development of computing in this particular way. So let me show you a little bit about what it was like at that time. There's a great YouTube movie. Let's see if we can get this going. Ed Murrow, who ran a show called on CBS TV in the 50s called See It Now, basically. Ed Murrow's basic show, which was a documentary show really on Saturday nights, had a clip from J. Forrester in 1951 showing us how one could program the Whirlwind computer and use it to actually simulate missiles in that sense. There's actually a very good movie directed by George Clooney, basically, called Good Night and Good Luck. It's really about Ed Murrow's show, basically. There's nothing about Forrester, basically, but it's a very interesting show because Ed Murrow was very much involved in current affairs and journalism and was a victim to some extent of the McCarthyism in the early 1950s in the United States. But let me show you the YouTube movie to give you a sense of what it was like in those days. Okay, so here we go. Now, maybe I'm not going to show you the YouTube movie. Let me have a look. See if we can get rid of this. Whoops. Well, maybe we're not going to see the YouTube movie after all. Yes.
With the new plants and additions now under construction,
maybe
annual production will be raised to £1,300,000,000.
we can hear the movie. But
you can hear the movie, yeah.
I think maybe if you stop sharing and reshare your desktop instead of the screen.
Yeah. Okay. Yeah. Okay.
Well,
this is just an advert from the YouTube movie to begin with. Let's see if we can bring it up. Okay.
These are days of mechanical and electronic marvels. The Massachusetts Institute of Technology has developed a new one for the Navy. It's a Whirlwind electronic computer. With considerable trepidation, we undertake to interview this new machine. Now to MIT and the computer lab at Cambridge, Massachusetts. Hello, New York. Hello, New York. This is Cambridge. And this is the oscilloscope of the Whirlwind electronic computer. I assume that, like any delicate, finely tuned piece of mechanism, this has a human element involved too, has it? Yes, Mr. Morrow. I am Dave Forrester, Director of the Digital Computer Laboratory where Whirlwind was built. Well, I wonder if we could take a look around, sir. Yes. Let's first look at one of the storage goods, such as the Whirlwind uses for memory. Whirlwind stores in these tubes information in 25 millionths of a second. And further down the row, you can see some of the electronic circuits which make Whirlwind work. Would you like to try to use the machine? Yes, of course, but I have an idea, Mr. Forrester. Since this computer was made in conjunction with the Office of Naval Research, why don't we switch down to the Pentagon in Washington and let the Navy's research chief, Admiral Bolster, give Whirlwind the workout? What's your problem, Admiral?
Well, Ed, this problem concerns the Navy's Viking rocket. This rocket goes up 135 miles into the sky. Now, at the standard rate of fuel consumption, I would like to see the computer trace the flight path of this rocket and see how it can determine at any instant, say at the end of 40 seconds, the amount of fuel remaining and the velocity at that instant. The rocket weighs 11,000 pounds at takeoff and carries an initial fuel load of 8,500 pounds.
All right, Mr. Forrester. All right, Admiral Bolster, we'll see what we can do. Let's look at the oscilloscope where the problem has been set up. Over on the left-hand side, you will notice fuel consumption decreasing as the rocket takes off. And on the right-hand side, there's a scale that shows the rocket velocity. The rocket position is shown by the trajectory that we're now looking at.
Okay, now I've stopped that because I've given you some sense of it basically, and we can go on and you can look at it basically. So let me bring the PowerPoint back. So I'm going to have to load it again. Where are we?
No problem. Yeah, I think we can see it. And I didn't know they had to phone each other on TV.
Okay.
It seemed like they had to phone each other while on TV.
Okay, so we're coming back up. Okay, so let's go back to this slide with Jay Forrester. Okay, so that's what you would have been seeing that basically. So if you go to the YouTube movie, the key point was that Forrester himself basically worked on the Sage missile project basically until the mid 1950s, and then effectively he moved to MIT. He moved to the Sloan School, basically, of management. He was a very influential man within MIT. He knew the president very well, basically, and more or less when the Sage missile project or the Whirlwind project ended, basically, the president of MIT, James Killian, I think at the time, basically asked him if he'd go to the Sloan School and introduce them to systems dynamics, because to some extent, dynamics was really pretty central to what he had been doing, even in terms of the Whirlwind project in this sense. Now, I'd never heard of Jay Forrester until 1969, basically. I'd been working at Manchester. I was on my way to move from Manchester to Reading to work on the modeling project as a research assistant. Before I left Manchester for Reading, I came across a new book from MIT Press called Urban Dynamics by Forrester. And this is really in the university bookshop where you saw new books in those days. I mean, there weren't that many books basically in terms of our field, and there are very, very few papers in a sense. One of the things about being in it right at the beginning, although I wasn't really actually at the beginning, basically, I was a grad student in a sense, one of the kind of key things was that over the years, you sort of met everybody in the field and you read everything which was really about it. And there wasn't that much at that time. So the Urban Dynamics book really came out of the blue. It's sort of, it threw a lot of new ideas onto the agenda, basically, in this particular context. And that's actually a picture of the book itself, basically. And what Forrester did in this particular book, he took a lot of these ideas about how computer systems and electrical systems worked in terms of positive feedback and so on, and he applied this to thinking about social systems, and in particular city systems. Urban dynamics was really about how a city would grow in some senses. And one of the key things was that it was based on the idea that cities grew or systems grew using positive feedback, not negative feedback. Positive feedback essentially leads to innovation, it leads to catastrophe, it leads to chaos, it leads to all of these non-linear dynamics, whereas negative feedback to some extent simply closes the system down, it keeps it on course. It's very much an equilibrium concept. So to some extent, this was a very new way of looking at things. It was not about incremental dynamics. The Tom's model, which Lowry, for example, was developed for the Lowry model, basically, the time-orientated model, an incremental application of a static model. Forrester was really quite different. It was all built around long-term booms and busts, basically, as we'll see in a moment. And of course, in the book, if you open the book and look at Forrester's dynamics, then you see there's a great deal of, and I'll show you a couple of pictures of this in a moment, a great deal of emphasis on non-linearity and how, for example, one non-linear system, non-linear set of relationships can lead to another. And can this lead to highly unusual sorts of behavior? Now, the model itself contained in Urban Dynamics was essentially a highly unrealistic model. At best, it was based on stylized facts. It was based really on using Boston as its caricature in some sense, but it really was very different from the sort of land use transport models which were being built in practice, basically, such as Lowry's model itself. So let me get back a little bit to Forrester in that sense and what he was saying. This was very typical of the kind of dynamics that Forrester was related to. Here you have, and I won't go into any detail, you have exponential growth, which is capacitated. It's sort of logistic growth to some extent. A system grows exponentially in some senses. It reaches a point where capacity, or the capacity of the system, basically constrains it in that sense, and the exponential growth is then damped, basically. And under certain circumstances, you can get wild oscillations of these curves, basically, but generally speaking, the logistic model, essentially, or the capacitated exponential in this particular context leads to behavior of this kind, that the system actually reaches a threshold and then sort of hovers around it, basically, in that particular context. That's very much characteristic, I think, of world population growth. We're heading massively, we're reaching the point of inflection to some extent on the curve, basically, over the last 10,000 or more years. And we're heading towards a situation where probably world population will be relatively, well, we don't know what it'll be like, of course, in a sense, but the implication is it'll be relatively stable. It will damp, basically, in this logistic fashion. Now, the key issue in terms of Forrester was that you have to have a system which is capacitated in some way. And of course, an urban system which grows, basically, in a sense, reaches a capacity if you fix it as a container. And this is essentially what Forrester built, basically. Of course, the way he did it was really quite outrageous in many ways. He's a very influential man in Boston, and he talked to the mayor of Boston, John Collins, and basically the two of them got together and basically the model, basically. And of course, Forrester didn't talk to any of the other people in modeling in this particular context. And so consequently, it was a sort of a completely new idea out of the blue, so to speak, in this sense. He'd also, of course, written a book in 1961 called Industrial Dynamics, etc., because he applied many of these ideas to the industrial firm, basically. He was in the Sloan School of Management, in sense, in this particular context. Okay, so let me just tell you a little bit about, and we'll come back to Forrester in a moment, but let me tell you a little bit about my own sort of entry into this particular field. I moved, as I said, from Reading University to Manchester in '69, and I was a research assistant on quite a big modelling project, basically. Peter Hall, who was the professor there, basically was the PI of the project. Peter, of course, never really worked in modelling in that sense, but he put the money together for this particular project. And as part of this particular project, basically, this was 1969, 1970, there was monies within the grant to be able to go on a trip to visit the pioneers of modeling in the United States. So eventually it fell to me to accompany my boss on this incredible trip in May 1970. Now, of course, I was 25 at the time, Eric was 31, Jay Forrester was much older than us, 42 basically. So we set out to America to talk really to the pioneers of urban modeling. So let me say something about America in 1970. Okay, you've got to remember that, first of all, most of the things that have been written on urban modeling we could get hold of and we could read basically. There were a limited number of people in the field, tiny compared to these days. And in 1970, America was a land of turmoil. The Vietnam War was in full swing. There was rioting on US university campuses. Tricky Dicky had just become president. That's President Richard Nixon of Watergate fame, basically. Taken over from the Democrats in that sense. One of the kind of key things was that we were going to visit a variety of people in the United States who had worked in modeling, such as Lowry, Britt Harris, people like that. Forrester was on the agenda. I'll come to that in a moment. We basically in Reading went to the travel agents, Cooks in Reading, and planned our trip. And there was a young lad who basically helped us in doing this, who had this massive book of all the airline flights in the world, who he'd never traveled himself. I think he'd very rarely been to London. It's only 40 miles outside of London. And so the world was very small in that sense. Coffee in America was largely free in those days, at most 5 cents a cup. We'd never really flown to speak of, and we got all the times wrong and even some of the places, basically. So in May 1970, we flew from Heathrow to New York, basically, Eric Cripps and me, to begin this 2-week journey to talk to people in modeling. We flew on BOAC. You won't know what BOAC means. It means British Overseas Aircraft Corporation, which turned into British Airways basically in the 70s sometime in that sense. We basically flew to New York and immediately then went to Philadelphia. Why did we not go straight to Philadelphia? Well, the guy who planned the trip for us didn't realize there was a flight from Heathrow to Philadelphia. We could have avoided all of that. So this really said it all. We saw Britt Harris, Dave Boyce, Walter Izard, and so on in Penn. And the next day we flew on the shuttle to Boston, basically, to Harvard and MIT. And we were scheduled for a meeting with Forrester himself in the morning, but for a whole variety of reasons, we couldn't quite get it in that sense. We did see John Kane in the afternoon, and then we went to Forrester's lab and saw James Hester, but Forrester was away for a meeting in that sense. The next day, so remember that we'd flown from Heathrow to New York, and then the next day, New York on the Metro line to Philadelphia, then flew to Boston, and then the next day we had to fly to LA. Los Angeles, and we saw Lowry at the RAND Corporation. Then we went to the Systems Development Corporation, and the trip continued in that way. We went through to Berkeley, and on the campus at Berkeley, the National Guard were there basically quelling the riots, basically. And so that's the first time I actually smelled tear gas in that sense, basically. And so this was an incredible trip, basically. We did get to see Forrester as Forrester's lab, basically, but not Forrester himself. Okay, now dynamics into urban models, a long and difficult question. One of the kind of key things was that Forrester had introduced, as it were, the fact that we could think about cities and model them in some sense, and computer model them using dynamics in that sense, based on positive feedback. His model was very heavily critiqued in that sense. Of course, it was not based on observed data, and there was a strong positive emphasis to modeling in those days. The notion of agent-based models with minimal data and so on, and maximum plausibility was not really on the agenda to some extent. So his was a wild development in this particular sense, and at best it was based on stylized facts. It produced exponential growth with capacity in that sense. But of course, one of the kind of key issues was that it was essentially non-spatial in many senses. The model basically didn't have space in it. It had time in it in that sense. So that was really quite contrary to what was really going on in this particular context. Now, there were several groups in the United States who attempted to extend the model and ground it in data. One of the kind of key things was that the Forrester model couldn't really be generalized spatially to many locations. And although there were a variety of attempts, basically, in a sense, it was very difficult to incorporate transport. And of course, critically, in US cities, it was very difficult to incorporate the suburbs, in a sense. So the suburbs versus the inner city was really the kind of critical issue. The whole notion of cities decentralizing in some sense in North America, which they were quite dramatically in those days, a lot of sprawl in this sense, was really simply not part of the Forrester model in sense. But nevertheless, we took the model to heart in some sense and began to think about building dynamic versions of the spatial interaction models. And here are some pictures from some of the influences that Forrester had on my own work. Here's a paper from Nature in 1971, written by myself, basically. And these are pictures from that particular Nature paper, and also from my book, the urban modeling book, basically. Chapter 12 really is devoted to this dynamic simulation. And what you can see here is an attempt, basically, to think about how to incorporate Forrester-like ideas into the spatial interaction. So if you actually look at the picture at the bottom, then you can see the sort of stocks and flows and the rates kind of logic, basically, in some sense, everything related to everything else, of course, in some senses, but some things more related than other things. So we have a network of relationships as one of the key things in terms of Forrester. And I can't go into this in any detail, but the small picture of the Reading area, Reading is a town of about couple of 100,000, I guess, now, basically. But that region, basically, was the one we were modeling. And you can see that the spatial, the number of spatial zones was probably about 25, 30, something of that sort. And of course, there was a balance to some extent between thinking about the dynamics of this. And if you look at the pictures of the, these are two of the zones, basically. Well, actually, the total dynamics between the time 1951 and 1966. So we were fitting basically this model to 1 year time periods between 51 and 1966. So the number of time intervals was reasonably consistent with the number of spatial units, in a sense. And that's something I think that's not been thought very much about in urban modeling, the extent to which the dynamics has to be as rich as the actual spatial interaction in this particular context. So you can find all of that in chapter 12 in my 1976 book, which is online somewhere, and also the Nature paper too, which is a shorter version of that in this sense. All of this was, as I said, was influenced really by Forrester in this particular context. Okay, let me continue. Forrester. Once the model had been, his model had been introduced, then he was really, I suppose, on a roll to think about how you could apply these dynamics to a whole variety of social systems. With his grad students, he then convinced a pressure group, a very influential world pressure group called the Club of Rome, basically, a group of the great and the good who are looking at long-term world population change and the notion that we would run out of resources, basically, in a sense. And he applied his system dynamics model to look at these long-term predictions. This led to his book in 1972, hard on the heels, really, of the urban dynamics book in that sense, called World Dynamics, basically, in which he applied these things in a world context. Now, of course, if you have a capacitated dynamics in some senses, then this can lead on a world basis to really some quite massive oscillations and catastrophes in some sense. And what Forrester demonstrated was that if you capacitated population growth in a sense, and you linked rich to poor and this kind of stuff, then you could really get a kind of crisis of a massive crisis of overpopulation. So to some extent, the world dynamic model is a dynamic model of really what Malthus was saying, basically, in 200 years or so before, 150 years or so before, about population outstripping the sort of resources available in that sense, overpopulation and the collapse really with not enough food to survive. So this is a picture of his World Dynamics book, basically, and again, the classic dynamics in some sense, which again, I'm not going to explain, but basically really talk about how these various relationships lead to these unusual and perhaps unanticipated changes. Probably not too unanticipated, because once you look at exponential growth, then of course all of these patterns are relatively easy to actually demonstrate in some sense. Okay, so the World Dynamics Club of Rome actually got very widespread popularity in some senses, to the extent that there were many critiques of it. The Guardian newspaper ran a thing, and of course our group at Reading at the time were fairly critical, I think, of Forrester, basically, although he was influencing us in many ways, he's fairly critical of Forrester. And we wrote a letter in 1972 to the Guardian. Now, this is a triumph of the internet age, basically, that last Friday, I took the tube one stop from Barbican to King's Cross, got out at the British Library and renewed my British Library card. And within about 20 minutes, I had a copy of the letter that we'd written to the Guardian in 1972. Not seen it since then, basically, and you can see it there. And I'll extract one of the things that we actually said, and this is really about the Forrester model. Let me read it out. We feel the subtle merging of sciences with sensationalism in this work is likely to bring computers into analyzing social problems into disrepute. The whole of this work seems to have been built around the computer, but we feel that the true role of the computer is that of a tool which should be used to explore rather than definitively predict the future. Our major point is therefore that it is Dennis Meadows and the Club of Rome, not the computer, which give mankind 100 years. And I think that must have been in response to something in the Guardian a couple of weeks before, basically, that really suggested that the world would last no more than 100 years from the sort of Forrester Club of Rome predictions in that sense. Okay, the continued path to dynamics. Now, this is a talk that's got bits and pieces from all over the place, basically, but it gives you an idea, I think, of how these different movements and developments begin to influence how we think about our world in this sense. Now, Forrester worked away at social systems for another 20 years. He passed away in 2016, aged 98. I nearly went to one of his last talks. I was at George Mason in DC in 2014, I think, not the same as the time when Schelling was there, but in 2014, he was giving a talk in downtown DC. So he must have been 95 at that particular point. I couldn't really quite factor it into my trip. I would have dearly loved to have actually gone and seen him, basically, in that sense. And to be honest, in some sense, aggregate dynamics has never really been broached in equilibrium models, and their time is now well past in that sense. So in other words, the kind of dynamics that we were doing back then 50 years ago is really to some extent not something we would necessarily want to repeat today, even if we had the data, basically. Other models, of course, began to take over in some senses, that if I were to continue this history after 1972, we'd be talking about aggregate dynamics, the Peter Allen type work and so on, Prigogine work. We'd also be talking about, with complexity theory, the development of cellular automata, clearly dynamic in that sense, agent-based modeling approaches, microsimulation, all of which to some extent really embrace dynamics in a somewhat different way. Discrete choice theory in transport? Well, not so much in that sense. It's mainly static in some ways, but a whole variety, a whole portfolio really of modeling ideas that really relate to the cutting edge in that way. Now, at this point, I think I should probably stop and just give you a few hints to where one might read a bit more about this. Clearly, chapter 12 in my Urban Models book, which is online, basically. That's the online thing, and we'll give anybody who wants the PowerPoint here in that sense. My semi-autobiographical essay in Beatrix Hasselberger's Routledge book in 2017 has got a bit in that, and there's the Nature paper from 71, and all J. Forrester's books from MIT and the Wright Allen Press are relevant in this particular context. And then the special issue of the IEEE Transactions on Systems Man and Cybernetics in April 1972 has quite a bit about how people have tried to generalize the Forrester model and to make it spatial as well as it being temporal. Okay, thank you very much, Clementine, and I'm going to stop sharing the screen, and we'll get back and we can then see each other. Okay, there we go.
Thank you very much, Michael. So just a reminder, you can post your questions in the chat. And until we don't have no questions yet, I would like to start the discussion. It was fascinating interdisciplinarity in your presentation. And I'm wondering what is the key science, if I could say so, because it's, I think, the combination of computer science that provides technology, a tool, a method. It's of course urban planning, but I would say it's more like a subject, a research area, and maybe there's also a role of geography, as you know, from a more theoretical side. So what would you think about this combination of science and their role, and what do you think is the key science in terms of this theoretical inspiration and contribution?
Okay, well, I think that I think one of the kind of key themes in all of this is that there really is no single science that drives, if you like, the development of these sorts of models in that sense. I mean, Forrester himself was an electrical engineer, but he was in the management school, and he knew, you know, as a sort of ordinary citizen, basically, he picked up a lot of these basic ideas and was thinking about the transference from sort of thermodynamics, I suppose, to something, not thermodynamics, from positive feedback systems and so on, cybernetic systems, into a kind of social systems in that sense. In other words, the whole nexus of the way models were developed basically was to pick things which appeared to be useful and relevant to how cities were functioning basically, and to mold them together and to use computing to actually enable them to simulation. One of the kind of key things that I didn't mention was that one of the things Forrester did, well, two of the things that Forrester did, first of all, in 1968, he had a computer terminal in his own home, basically. He says that at the beginning of the Urban Dynamics book, which is really very interesting, that in the 1960s, somebody would have a kind of a computer terminal in their home. I mean, the PC wasn't invented for another 20 years, basically. That's the first point. The second point was that he used a kind of computer graphics. He used the line printer to produce these pictures, basically, of the graphs, basically, because basically computers in those days simply were painful to actually program, and graphics was actually done in this very fast way on the line printer itself, basically. That doesn't quite address your issue. Can you rephrase, Ruta, what you were saying about what the kernel of your question was? I got it as being interdisciplinary and putting different things together, but you were asking me something specifically.
Yeah, which science contributed in terms of this theoretical, I know, inspiration, or who had the first
Well,
theoretical ideas?
you see, basically, when urban models began in the 1950s, it was largely due to policy in the United States. The interstate highway system, was being put into place in the 1950s. Car ownership in America was very high. I think it reached something like 50% in the early 60s, the middle 60s. Cities were spreading out basically. A massive movement of people to the edge of cities and so on. Downtowns were declining and so on. And these models were really built to try and originally deal with these sorts of problems, basically, in that sense. And there's a variety of urban economics, etc., which was used, the Alonso model and so on, sort of a lot of the regional science models and urban economic models really represented the sort of theoretical underpinnings of things like the Lowry model and so on. So economics, regional science to some extent, the systematic sociology for that matter, the Chicago School and so on, all of this stuff came together really to actually develop these models. And if you looked at the people who were developing them, they were a great bunch of, a wide bunch of different disciplines, basically engineering, of course, to some extent, economics, physics to some extent, and so on. So really, almost every discipline you could think of somehow got itself reflected in the origins of these models, basically, in this particular context. Forrester was somewhat different. He came at it from a very different perspective, but it was soon embraced within the modeling movement in some sense. He came at it really from thinking about cybernetic systems, which were based on ideas about feedback and so on, which I suppose to some extent are reflected in the kind of computational technologies that he was working with in that sense. So to some extent, it's very hard to actually identify one single discipline. It's very hard to get the mix of disciplines right, but there was this enormous mix of things, and it was very practically focused in that way.
Yeah, thank you. And also, Denise has a very much related question. She asks why Forrester's model is so much inspired by hydraulic dynamics.
You want to have a look at that? Denise says, hang on, I'm just...
Yeah, it's in the chat.
Well, she says Denise.
Yeah, it's before, a little bit up.
Hydraulic dynamics, okay. Yeah, I guess there's an element to that in it. What was your question, Denise? I'm just trying.
Mike, I was wondering, you said he was an electronic engineer, and indeed, dealing with stock and flows and varying the ratio by connecting recipients and throwing flows from one to the next. I always understood the model as being a kind of a hydraulic model with different compartments being receiving flows from the other with and having a capacity to be more or less full and so on. What do you think about this kind of analogy? Indeed,
right.
yeah.
Yeah, I agree with that. That to some extent, there's really two ways of looking at it. One is the more aggregate way in which you have these capacitated growth dynamics, really, in that sense. And the other way, of course, is the relationships between them, which really relates to the stocks and the flows, basically, over time. And in some senses, his systems dynamics, I think, is a general way of embodying nonlinear dynamics and complicated non-linear dynamics, where you have several types of dynamics that are linked to each other. And the links, in fact, are the stocks and the flows in this particular context. The stocks, of course, are created at the point in time, and the flows actually change it in that sense. So, so both ways, I think, are ways of thinking about it. The little diagram I showed you of our own stuff, basically, was a sort of an attempt, really, to think about the kind of the spatial interaction models, the dynamic version or Forrester-related version of our spatial interaction model in terms of stocks and flows. Let me see if I can share. No, perhaps I won't share it again. Hang on. No, I was going to share it again. I don't think I will. Sorry.
No, but I see the diagram very well. Yeah, thank you.
Okay.
And I was in the chat mentioning that rather early, I think at the end of the 70s, there was an attempt by a former student of Pierre-Henri Derick, urban economist, to design a model using Forrester's formulation and even the dynamo language, but for introducing a spatial interaction, I think between the center of the city, a first suburb and the further suburbs. So he had, yes, I think it's 3 aggregated spatial places. And he succeeded in testing this model on the small town of Carpentras in the south of France.
Okay. Yeah.
I will try to find again the reference.
There is a paper on that. I've not seen that. I mean, of course, interestingly enough, it's like many of these things that once the wave of interest in Forrester had passed, and it did pass quite quickly, I think, really, probably by the mid to late 1970s, then people did continue to work on it. But of course, in some sense, a lot of the stuff didn't see the light of day. So what you've just said, Denise, is very interesting. That I think if we did a survey of all the work that had come out of urban dynamics, it would be quite substantial, basically, in that sense.
Yeah. We had 3 weeks ago in Heilbronn, Germany, closest to Stuttgart, organized by Günther Haag, a meeting of the Steinbeis Institute about the 50 years of the Meadows report of the Club of Rome. Interestingly, it was about modeling, territorial modeling. And of course, all the presentations dealt with new types of models, which no longer are in the same philosophy than Forrester.
Right, very interesting.
Okay, we can continue. There's another question in a chat, Michael, maybe you can see it also. And if I understand it correctly, it's about what did Forrester think about agent-based modeling and cellular automata?
Well, let me have a look. Where is that in the chat?
Right after Denise's first question.
So it's a question by Keith Waters. Do you have a sense of how he might have felt about or feel?
Yeah, okay, that's a very interesting point. I mean, in some senses, if you'd asked me the same question myself in 1970, agent-based modeling was just, I mean, the term wasn't really involved in that, but cellular automata modeling was to some extent. But again, in the very early origins of complexity theory and so on, John Conway's Game of Life was something like 1970, 71, something of that sort. So to some extent, I suppose my answer to that is how would, you're asking how would Forrester felt about ABM or CA in some sense. He might have known a little bit about CA because, you know, he was quite close to the Manhattan Project, and Stanislaw Ulam and John von Neumann and so on were sort of playing around with CA in this particular context. So he might have had some views about cellular automata, which was clearly related to the dynamics of patterns in a sense. ABM is, I think, a generic tool or technique. It's like microsimulation to some extent. It can be applied to all sorts of things. Cellular automata too, to some extent. One of the kind of key features, I think, about the history of these models was that the models themselves were built really without any specific set of ideas that came from an analogous area, from physics or economics and so on. I suppose to some extent input-output modeling and that kind of macroeconomic modeling had an influence on urban models, basically. But urban models put together their own theories. So if we talk about land use transport models, when we contrast them with cellular automata models or with agent-based models, we're not really comparing the same sorts of things, because ABM and CA are sort of tools and techniques, really, to think about building models in that sense. Arguably, the sort of Forrester systems dynamics is a set of tools that can be applied to lots of different systems, whereas the way gravitational models, spatial interaction, discrete choice, and so on, economic-based models and so on, really reflected in these models was fairly specific to cities themselves, basically. You don't find an equivalent, really, in other spatial or social systems. So that would be my reaction. How would Forrester have felt about it? I don't know, we'd have to ask Denise, because Denise, you said that you met him in 1981 in Boston in a conference on systems dynamics. Very interesting. So Denise, can you answer that question? I mean, what do you think?
Oh, thank you, Mike, for asking. But
Well,
at the time, I was a very young researcher and not very keen in ensuring conversations in English, and I didn't have the opportunity to speak to him directly. But we listened to his conference, and it was really a kind of convergence of the participants of that conference from a variety of disciplines on this way of presenting dynamic models and using simulation with the computers for analyzing evolutions in many directions. He was not at that time speaking so much about the conclusions of the Club of Rome. I was surprised to have almost no echo from that, but it was all about the methodology of system dynamics. And a few months later in Brussels, it was, at least to me as a social scientist, I was much more convinced with all the applications that Prigogine and Peter Allen and de Neubourg presented of the self-organization, mathematical models, and their simulation. So sorry for not having something to add to the personal knowledge of Forrester.
Yeah, thank you, very interesting. Clementine, please go ahead.
Thank you. Thank you, Mike, for the presentation. My question was, would you say the model and his different models, so urban dynamics, but also world dynamics, had a longer lasting effect on policy than it had on the scientific or the modeling community? Because I can imagine, well, from what you're saying, it was not fully satisfying to urban modelers already in the 80s. It was already sort of outdated quite quickly, but I can imagine that it was quite popular in the policy world because you had a sort of a switchboard where you could change things and act on the system, and the impression that all the factors were in the model because you've got a lot of the factors within the models. have the impression that it is still popular and it's still shaping what policymakers expect from a model of cities? Or
well, I think, yeah, I think that I think there were impacts from, there have been impacts from the Forrester's model, the whole tradition, both on the field of urban modeling, which really relates to grappling with this idea about dynamics. Denise has mentioned Prigogine and the whole sort of development of self-organization and dynamics and so on. But Forrester too, I think, had a lot to do with pushing the field in a very implicit sort of way towards thinking about dynamics. I mean, even before Forrester, people were thinking right at the beginning about dynamics. They couldn't do anything about it, as I said, because largely, you know, the data wasn't there. In some sense, the theory wasn't there for that matter in that sense. But nevertheless, people still thought that, you know, if you're dealing with change in cities, it's got to be dynamic in some sense. I don't think there was ever a view, certainly not in this particular field, that cities were cast in equilibrium for all time in that sense. So I think that he had an influence on dynamics, but in terms of policy, there may have been some impact in some sense, but again, I don't think it was very specific, because basically his model of, which loosely relates to Boston, is really one zone. It's basically the inner city, basically. And if you capacitate the inner city and you relate the growth of population to the wealth of the city and so on, which to some extent he did in urban dynamics, then basically once things get full up and you get sort of leads and lags and so on between the variables, then essentially the population began to drop. And I think he did have a simple disaggregation between different income levels, basically, in a sense. So it was slightly disaggregate in that sense. Basically, it led to an undesirable sort of situation. You couldn't do much about that because there were no safety valves. The safety valve would have been to add a suburb or something like that. And that's what people began to do, I think, when they looked at his model and thought about extending it in some way. So in some senses, I'm not over convinced that there was a strong influence on policy, but there were probably a stronger influence than many of the what we might call the mainstream urban models, because the mainstream urban models really weren't developed with any specific policy issue in mind, whereas the Forrester model was. He talked to John Collins, who was the mayor of Boston, and the critical issue about Boston was, I mean, this is back to America in 1970. You know, they were burning the cities in 1970, basically, and this was happening as much in Boston as it was in DC or anywhere like that. And in some senses, these were the problems, the sort of the decline of the inner city. So from that perspective, I do think there might have been some influence on policy. But of course, in many ways, the models really couldn't tell you very much what to do about it, in the sense that somehow the long-term outcomes were basically built into the structure of the model in the first place, basically, in that sense.
Okay, we have a lot of questions, actually. They are in the chat. And Junie, if I pronounce it well, asks, how would you describe or estimate the influence of the mental model simulation of Forrester to future prediction in architectural context, especially in urban modeling and socioeconomical changes? Can you see the question? Or
yeah, I can see the question. Yeah, I've got the question.
Mm-hmm.
Junie, if you're still with us and you want to
I asked
your question, you're welcome.
Okay. Can you elaborate it, Junie? I mean,
no, I asked Junie. She doesn't have microphone. So.
Oh, okay. No, I'm just trying to think. Well, I suppose in some senses, all models are mental models in the sense that they are our perception. I mean, I think one of the things that was outrageous about Forrester model was that he never talked, at least, you know, I mean, this is third or fourth hand basically, but I don't think he ever talked to the people who were building the models. And there were many of them, you know, Lowry, Britt Harris, William Goldner, you know, John Kane, a whole variety of different people. Of course, Forrester was at MIT, and he must have known Leontief at Harvard, and you know, and John Kane and people like that. They must have met, I suppose, in some sense. It was a much smaller world in those days, and so in some senses, what Forrester didn't do, and I can imagine this because of his background and his position and so on, he didn't really involve himself in what was going on with other sorts of models. And I think that was the outrageous bit, because basically had he done that, he would have probably realized that transportation is pretty central to some of these urban issues, and issues about centralization and decentralization in cities was all important and so on. And he didn't do that. So I think there was a sort of sense in which the model was incomplete. It could have been influenced and developed more appropriately and probably had a bigger impact. But of course, his impact was to do it very quickly. I mean, in the World Dynamics book, which is the predecessor, the immediate predecessor to the Club of Rome. The Club of Rome model, I think, was the World Dynamics model, basically. Basically, what Forrester says in the preface, this is from memory, I've not looked at it recently, but in the preface, he says that basically he ran this model, or he worked out all the dynamics of this model on the plane from Boston to Zurich or somewhere like that, basically. He says something like that in the book, which is really quite outrageous, you know, in some senses. These people painfully struggling to build these models over months and years under terrible circumstances. And then Forrester just sits on the plane and writes down the equations and takes it back and plugs it into his system dynamics model, and they have a world model in a sense. So it was that kind of hype, really, that kind of throwaway line, I think, that didn't endear him to the wider constituency in that sense. And in some senses, it's as much to do with the sociology of the field, basically. The fact that he didn't really use data in any sense. The data he had was what John Collins thought about the inner city in Boston. So, and it wasn't actually based on looking at census data and a whole range of different things of that sort. We, when we flew from New York, from Philadelphia to Boston, basically on the second or third day of our trip, basically back in May 1970, we missed seeing Forrester largely because you know, we got tied up at the airport and we had to work on, I mean, you know, you've never been to these things before. There was no email or anything like that in those days. We had to figure it all out from scratch, and it just took us this long to get from the airport to actually Harvard, MIT. By that time, we'd missed our meeting with Forrester, but we did see James Hester, who worked in the Joint Unit for Urban Research between MIT and Harvard, after we'd seen John Kane at lunchtime, because John Kane was building these econometric models. We then went down to see James Hester, who was a postdoc who was working with Forrester. And Hester was actually beginning to think about generalizing the model and tuning it in a bit more to what was actually happening in US cities in this particular context. So it'd be wrong to, it would be wrong to consider, I think, Forrester to be completely out of the broader picture in some sense. He was obviously a very busy man. He had a million things to do, basically, in a sense. And so consequently, the fact that he didn't get immersed in the embryonic urban modeling field, basically, one can't really blame him in that sense. But nevertheless, I mean, looking back on it, the Urban Dynamics book, I think, has been quite influential in terms of the history of this field, definitely.
All right, and I would like to ask Javier or Xavier, I'm not sure how to pronounce, to ask a question.
Yeah,
thank you.
thank you, Ruta. Thank you, Mike, for this great overview of the model. I had a question regarding, you were basically ending the presentation saying like, nowadays these models has been clearly superated or overcame by much better modeling techniques. But I was curious as well, which is the value that we can find of those models? Can we recover part of these dynamic models from the 70s to current modeling approaches, or we just need to consider them completely as a legacy method that has no value for current practice? Because there are like some assumptions about the equilibrium, as you were mentioning, that could be even controversial for current from current data, from current observational information.
Can you could you say that again? Can you, I kind of missed to some extent the key bit.
Yeah, basically, do they have any value? I mean, can we reuse? Can we recover? Can we use them for part of our models nowadays? Or we have much better techniques these days. Can we use part of what we learn from these models nowadays, or, as you were saying, switch to any other approaches?
No, I think we can, and I think that's what the great challenge is. We have all of these different approaches: agent-based cellular automata, LUTI, land use transportation models, and so on, econometric models. We have a whole variety of modeling styles and techniques, of which the Forrester one is to some extent important because it looks at dynamics and it looks at relationships between dynamic variables or variables that change through time in this particular context. And I think there are little bits of these things that are potentially built into many modeling schemes in that sense. There is a tendency, I think, to take a particular modeling approach and to work around it, etc., and to then not build other types of modeling approaches in. But I think there are examples where it is possible to put these things together. I mean, back what we did in 1970, basically, where we took our spatial interaction models and we sort of said, okay, we do have a time series between 1951 and 1966, as it was. That was the data in those days. We could actually build some plausible relationships between the different zones, etc., operate them through time in this particular way. And what it did lead to, essentially what our spatial model, spatial Forrester model, if you like, in a sense, led to was a kind of dynamics at the zonal level, which was reminiscent of the kind of unusual dynamics that you got at an aggregate level in the Forrester model. I mean, at one level, the Forrester model for Boston, the inner city model, basically simply had population growth that then oscillated around some rather sort of unsustainable sort of equilibrium, basically, in a sense. The world dynamics model led to all kinds of collapses and so on. When we applied those ideas to our spatial interaction models, what we found that some of those dynamics were reflected not at the aggregate level particularly, which was control, but at the disaggregate level in terms of the zones and so on. So I think that's an example of where one school of modeling, if you like, can be reflected in another. So I'm very much a believer in the fact that we need to select the best from each. In some sense, we don't have a general theory of the city and never will have, basically, notwithstanding, you know, urban science and all that sort of stuff. I don't think we're ever going to have that kind of thing. There's almost as many theoretical conceptions of the city as there are people actually in cities, basically, in that sense. So I think from that point of view, we have to be eclectic about the techniques themselves and pull things together. So the answer would be, yeah, eclecticism, I think, is a good thing in this particular context. Let me just, there's
Yeah, there was one more question from Denise.
There's one from Denise.
Yeah, it was.
That's not very important.
No?
It was about did Forrester influence the ethnic group who made a lot of urban models for Britain with policy applications?
I don't think that I don't think the Forrester model had a very strong influence at all on ethnic stuff in some sense. His models have always remained, until he sold his company, you know, 10 or 15 years or more ago, all his models were essentially cross-sectional static models of the Lowry type. And he always added a very strong supply side to the model, basically. So the variants of the Echenike model now, such as the one Ying Jin is developing, which is Li Wan and so on, Louisa and variants of that sort, they really, the big difference between the original Lowry models and the Lowry vintage type models and those Echenike models is the supply side. Lowry didn't really deal very much with the supply side, but in the Echenike models, then the supply side is really dealt with. I'm not convinced that Forrester had any major impact on Marcel Echenike at that point. Incidentally, in 1972, there was a conference over in Cambridge which Marcel Echenike ran, basically, on urban land development models. And there was a chap called Leo Kadanoff, who was a physicist from, very well-known physicist, basically, in scaling and complexity and so on. Kadanoff was at Chicago, and he was somebody who'd picked up the reason why he came to the conference, because he was actually working with a variant of Forrester's model that he'd actually picked up. I think in the special issue of the IEEE, there is a paper by Kadanoff about his variant of the Forrester model. And I think he was one of the several people who tried to generalize it spatially in that sense. But I don't think that Echenike was much influenced by Forrester at all. Now, there was one other one from Keith Waters, which is through you, Clementine. And this is this question about Forrester and SimCity. I don't think that SimCity had much to do with Forrester either. SimCity was written by somebody called Will Wright, who's a games person, and it goes back about 30 years. And there is a book on SimCity, well, many books on SimCity, but this book by Will Wright. And Will Wright says that he basically got many of the ideas for SimCity from a group of people at MIT in planning, in urban studies and planning, mainly Joe Ferreira and Lionel Wiggins, basically, who are mentioned in the book, basically. And one of the interesting things about this book by Will Wright about the original SimCity is that he does explain gravitational models in the book itself. Whether or not gravitational models are part and parcel of the early SimCity, I don't know. But there was a stronger influence on what you might call mainstream urban modeling from SimCity than from Forrester. Of course, I may not know on this particular point. I don't know whether, we'd have to ask Will Wright, he's still alive, I think, whether or not Forrester's model had actually influenced it, because SimCity is dynamic in that sense, for obvious reasons. All games are dynamic in that way. Yeah.
Thank you. So we have another 5 minutes, and there was a very long question. I might just ask you one element to try to summarize it. I think so. Marcus wanted to make the point that most cities rely on resources that are part of the outside of the city. So environmentally, they're dependent on what happens beyond the boundaries of the simulated city. Do you think that makes Forrester's model obsolete? And well, most of the models that are similar, because they don't account for the resource supply. I guess that's not modeled within the city.
Well, I think that's a very obvious and important criticism of Forrester's model itself. I mean, Forrester basically, what he didn't do, which is a little bit surprising given that he was a systems engineer, although, you know, there's different sorts of systems in a sense, but what Forrester didn't do was to make a distinction between, at least I don't think he did, he didn't make a distinction between the system and the rest of the world. I'm not overconvinced that that's quite right. I think he might have made that there are some elements in his model that pertain to the rest of the world. So in other words, the difference between the system and the environment. I mean, if you're building a model of just the inner city, if you go back to 1970 in America and you just take the inner city, then most of what's in the city is not contained within the inner city in that sense. If you don't have transportation between the inner city and everywhere else in the city, then again, it's very incomplete. So to some extent, that's a bit like saying, if we exclude the rest of the world, the important bit of the rest of the world, that's the thing that is really pretty central to how we should build good models today. Having said that, one of the reasons why, I mean, we have this model in CASA called Quant, which is basically a model of England, Scotland, and Wales. It's an urban model. It's at the same sort of level of the kind of models that you're talking about in this series. An urban model, it's a land use transport model, but it's for everywhere, basically, everywhere except Northern Ireland, because obviously you can't drive to Northern Ireland and so on. So in some senses, the reason why we did this is because many of the policies that are involved now are global in some sense. If we build a new Crossrail or high-speed 2 or something like that, it's national anyway, in the sense that we need to look at the impact right across the piece, so to speak. Arguably, we need a rest of the world sector. If you model the city of London, you can't model that without actually modeling all the other sort of global hubs, basically, that actually make a link to them. So this notion of closing the system to the wider environment is something that we really need to take to heart. I mean, systems theory tells us that that's the way you define a system, you know, in the sense that you identify the environment, but in a global world where everything influences everything else, then to some extent, we really have to think very hard about this whole question about where we draw the boundary, basically. It's very much to do with Matt's comment from Herbert Girardet. Okay, what is 120 times the size of London? The answer, the land or ecological footprint required to supply London's needs. Yeah, of course, which is probably the rest of the world, basically. I mean, in that sense. So that's a big issue. I mean, it's a big issue to do with spatial definition, I think.
Thank you very much. Thank you very much for keeping the time to the minute. So a round of electronic applause for Mike. Thank you very much for presenting today. For everyone, if you want to join us next month, it will be on the 13th of June. We're receiving Samrita Sarkar to talk about utilitarian models and urban resource allocation. Once again, thank you for everyone who contributed to the discussion, and thank you to Mike and Ruta.